Okay, so home assignment discussion. Create a list with dog, monkey, and banana with us. So this is quite easy. We have list one equals list dog, monkey, and banana. Does it work? We can test it. Okay, execute. Mm-hmm, mm-hmm, mm-hmm. Obviously, forgot the square brackets. Good. So this works. We even can simplify this a little bit. Just use the square bracket notation. Execute this as list 2. And it works. We even have the option to start with an empty list. Now let's put this together and then use the append method to enter the elements one by one. Dog, monkey, banana. So far, so good. Easy. Add bird to the list, so we can go list one, append bird. Very good. We can list two dot insert, for example. We can check insert index object. So if we want to add the bird in front, we put bird. Careful, don't execute twice. Now we have one bird in front. If we execute again, we have two birds in front. So what else can we do? Right. We can use list 3, expand, and now we can add a list of birds. So we have, for example, a sparrow and an eagle. What happened? Expand. Oh, sorry, not expand, extend. Right. Good. So what do? We don't like bananas anymore. Right. So let's see. Check one. What do? We can delete a banana. Actually, remove banana. Very good. So this works. What else can we do? In principle, we can ask list to pop the banana. We just need to find the index, right? So let's look at list 2. Banana is at 0, 1, 2, 3, 4. Right, always start counting with 0 on Python. So pop element 4. It tells us that the fourth element is banana, but it also deletes it, right? There's a popping, like a balloon, and then you pop it, and then you don't have the balloon anymore. But the pop tells you, well, I used to have the balloon. Good. Next one. Order the elements in the list by alphabet. So list one dot sort Does it work? This one. Yes, this works. Let's try list3.sort. Yes, also works. Very good. So sort actually can do a little bit more. Right, you can provide a key that basically is another feature that is looked at to do the sorting decision. For example, you can sort list3 by the length of the element. So we just put in length, just need to unlock the keycaps, keys, length, and show what you have in list3. So the short strings should be in front of the long strings now. Okay, very good. Make a list with food for the animals. Let's see. In list 1 we have bird, dog and monkey. So my food list, equals, I don't know, do bird eats, bird food. Very creative. And then dog food. And lastly, monkey food, but I know bananas. Good. Done. Nothing new. So the next one is a little bit more, well, an exercise in Python. So what can we do? We can make a list using the zip function, providing list1 and food list. There we go. So this already pairs now the bird with a bird food, the dog with a dog food. You see, we wanted to have animal and the food. Now, if you pay close attention, actually in the zip list, we don't have a list of animals and foods. We have a list of tuples with animal food. So to change this, we could, for example, typecast using the list method in zip list. There we go. Okay, not too bad. I have a numbers solution, which is a little bit more complicated. Let's see, what do I do here? Yeah, let's try. So the second solution could be zip list equals list of zip, and this time we provide a list to zip. Let's look into my zip list. A little bit different. It's now one more nested layer in case you haven't figured out what zip does. Right? It basically joins lists. Right, so what the zip object yields an n in a tuple where n is the number of iterables passed as positional arguments. So you have one list, you have another list, you put them together in zip, and you get a new list with two columns or in a nested format, so to say. Good. So when we pass the two lists as an inner list to zip, then we need to work around a little bit more. Right. And secret here is to understand the structure of the nested list, right? So indexing notation here gives me the first part, here the second one, and as you see, the nested list are still separating the animals from the food. So what I want to do is I actually want to select the first one here, but this is just a tuple containing that list. So to go to bird, I need a third one, right? And go to the bird food, I need to do similarly, right? So this is the innermost, that is the tuple containing the innermost list, and that is the outermost list. Good. And when I have this, and I'll just combine them, say these form a new element, a list, right? Bird and bird food. And remember, I I run over the innermost loop, right? So if I go to the next element, I need to change the third index position, not the first, not the second, third. Good. Right? Dog food. But when I have understood the structure now, I can say, instead of doing it by hand, I use an iterator. Okay. So I here is the iterator that takes a numerical form. So we need to use range length of, well, however the length of the list inside one of the tuples are, because it's still like a one-to-one mapping. Okay, so and we close the list comprehension. And we got the n. Okay, dog food, dog food, dog food. Forgot to adapt the iterator. There we go. Okay, so many different ways can give the same result. I actually have two more solutions, but right, no need. Select all animals with more than 3 letters. Okay, so let's see. We need to select. What we can do is again a list comprehension and check the length of my elements in list 1, for example. Right, so we have now 4, 3, 6. Is this correct? Let's check. 4, 3, 6. Good. This expression in the list comprehension we can convert to a Boolean statement. True, false, true. Okay. So this is a list, and this list we can use in an inline if to return a list element or not. Let me think how to do. So return j if true, else none. For j in list 1, right? But list 1 is still a list of animals. So what we need to do is check if the length, right, is true or not. So we paste the conditional statement, adapt the iterator, don't need this anymore. Pass this to a list method. Okay, there we go. Bird null monkey, right? So dog has not more than 3 letters, so replace this with null. It goes a little bit easier if we use slightly different syntax. So what do we have? J for J in list 1 if len J just 3. Right, so these are list comprehensions or inline ifs, slightly different notation, right? But we still get rid of dog. Good, what else do we got? Change dog to fish list 1. Okay, here we have dog, that is the first element. Also easy. We can do a little bit more. We can loop and have a conditional test. So let's see what other list has dog list 2 for J and list 2 if J equals dog. J equals fish. However, if you execute this, you have never really changed list 2, right? So what you need to do, you need to enumerate list 2, get your index iterator, and then say that not J is fish, but the element in list 2, right? And now we change from the content to the counting iterator, right? Good, let's try. So we go to fish. Okay, so check if all elements of a list of animals are numbers or strings. So let's check list 2. Let's get an element that is alpha. Alpha, this one. So this is true. Okay, so we can loop again. Is 2 alpha. They're all. Oh, what is alpha? Well, alpha checks if you have letters in a string. Alpha. Return true if the string is an alphabetic string. Right? Alphabetic string, letters. We can have something else. We can have alphanumeric, so letters and numbers. We can have numeric, right, if we have numbers. No, we don't. Let's see, we have list 2. List 2 is what? Okay, we append. How about 4 cats? So now we have numbers and letters. Is it numeric? No. Is it alphabetic? Ah, you see, for cats is not alphabetic because it has numbers and letters, but it's alphanumeric. Okay. Good. I'll check if numbers or strings. We basically did that. Very good. So sets make a set of even numbers. So set A equals set range 0. Let's do the 10. Let's say 10 in steps of 2. Set A. Okay, these are even numbers. We can have a set B. Starting with an odd number gives us odd numbers. Set A the union. Set B. Okay, good. Intersection set of prime numbers. Okay, so set prime numbers equals set of 2, 3, 5, 7. And we need to check if the union has an intersection. Set union intersection with my prime number set. Okay, and we got the prime numbers, right? Change. Change 4 into a tuple, no problem. Tuple set of prime numbers, because the intersection with prime numbers is identical to my prime numbers. Okay, that's about it.